कौन सी बुक से लेते तुम लोग? फ्रॉम विच बुक दे टेक क्वेश्चंस, सैंपल पेपर्स? कोई ऐप है क्या? ऐप से लेते क्या? मुझे भेजो ना।
हेलो। वो तो गया है लेकिन फेसबुक लोग चाहिए।
9028 177 296। भेजो ना। कहाँ तक हुआ था? नहीं, मैथ्स नहीं, फिजिक्स भेजो ना। अच्छा, इसको शुरू करना है ना?
सेक्शन में हो गया।
हम्म, ठीक। ओके, शुरू करते हैं। सेक्शन ए हो गया था, सेक्शन बी से शुरू करते हैं। क्वेश्चन नंबर 12 ना? ओके, क्वेश्चन नंबर 17। See, the question number 17 tells us about in which situation is there is a displacement current but no conduction current. अब ये डिस्प्लेसमेंट करंट क्या होता है हमने पढ़ा है, ध्यान से समझना है। मैंने एक कैपेसिटर के प्लेट्स ले लिया बेटा। सपोज देयर आर प्लेट्स ऑफ द कैपेसिटर, इन बिटवीन देम देयर इज अ गैप। विच गैप? लेट अस से देयर इज अ वैक्यूम इन बिटवीन देम। उनके बीच में वैक्यूम है। इसको हिंदी समझती क्या? आपको हिंदी समझती? यू डोंट अंडरस्टैंड हिंदी? ओके ओके। So there is a capacitor of capacitance C, and in between them there is a gap, and in that gap, let us suppose there is a vacuum, and some AC source is connected across the capacitor. So what will happen when AC source of potential E of t is connected? We know that AC source changes the potential sin omega t, right? We know sin omega t. So AC source, what does AC source do? It changes the potential with time. So due to the change in potential with time, the charge on the capacitor, the charge on each plate of the capacitor will also change, because sometime it will be positively charged, sometime it will be negatively charged. During positive cycle, this side will be positive, this side will be negative. What about during negative half cycle? Negative half cycle, there will be negative charge on that on the left side and positive charge on the right side. Okay, so polarity of voltage changes as per the time goes. Therefore, EMF will look like this, as a pulsating voltage. AC source will be a pulsating voltage, something like this. Sometimes it will be positive, sometimes it will be negative. Then alternate positive and negative occurs. So we know that an equation for capacitor is Q is equal to CV. Q is equal to CV. Here, the applied potential difference across the capacitor is E, and therefore Q of I can write Q of T is equal to C times E of T. Since the potential across the capacitor is a function of time, the charge on the capacitor will also change with time. And since the charges on each plate of the capacitor is changing, we can say that there will be some current flowing through this wire, right? There will be some current flowing through this wire, because current is what? Current is nothing but dq by dt, rate of flow of charges. So because charges are changing on the plates of the capacitor, dq by dt exists. Okay, so therefore I can conclude that some current is flowing through these wires. But the problem here is there is a gap, or there is no conducting material between the plates of the capacitor. So how come this current will be produced or will flow between the gaps of the capacitor? Okay, we know that the current flows through this wire, because the potential of difference of the across the capacitor is continuously changing, so charges will flow. But these currents which are flowing through the wires are known to be conduction current. We call it conduction current. But because there exists only electric field between the plates of the capacitor, so we can say there is no conduction current between the plates of the capacitor. We introduce a new type of current that is called as displacement current. We call it displacement current. So displacement occurs. Displacement current occurs only when the electric field between the plates of the capacitor changes. Notice what if I connect the DC battery across the capacitor? Because of DC battery, there will be no current, because once the charges are shifted to the plates of the capacitor, once the capacitor is fully charged, there will be no further flow of charges. The capacitor is fully charged with DC battery. Since the DC battery doesn't change its potential, I can say the charges on the capacitor will also be constant. Okay, since the potential across the capacitor is constant with DC load, it will be charge will be constant, so there will be no current. Dq by dt will be 0. So you remember that the displacement current, what we have introduced here, is flowing just because of AC current. Okay, due to AC source only, the capacitor has displacement current between the plates. That means displacement current occurs only when the potential across the capacitor is changing. And due to the change in the potential, the electric field across the capacitor will also change. So therefore, it can be concluded that displacement current only occurs when there is a changing electric field or changing electric flux. Therefore, in Maxwell's law also, Maxwell only introduced what? Closed integral of Ampere circuital law. Do you know Ampere circuital law? B bar dot dl bar is equal to mu naught times I. So what this I is? I is nothing but conduction current. So Maxwell added one more thing, that is displacement current. Okay, because when someone has noticed here also electric field, along with the electric field there exists a magnetic field, because compass is showing the reading. So that means whatever current is doing, current produces magnetic field. So we are getting magnetic field between the plates of the capacitor also. This is why it is assumed that there is a current exists called displacement current between the plates also. Although there is no flow of charges, literally there is no flow of charges, but still something exists which looks like current, because it produces magnetism also. So changing electric field also produces magnetic field. So whatever a current is doing is done by the changing electric field. Therefore, we conclude that the displacement current is nothing but is directly proportional to rate of change of electric flux. Rate of change of electric flux. So therefore, displacement current is nothing but is equal to some constant times d phi by dt. Now, what is phi? Phi is nothing but electric flux. Phi is electric flux. How can we write electric flux? Do you know the formula for electric flux is BA cos theta? Sorry, EA cos theta. Electric flux is EA cos theta. See, electric flux or and magnetic flux. What do you mean by electric flux? Number of electric lines crossing the given area. So electric flux can be calculated by E bar electric field ka dot product with area vector. The dot product between electric field and area vector gives you electric flux. Therefore, displacement current becomes displacement current becomes E naught epsilon naught A dE by dt. This is the expression for displacement current. So we have given the answer for this question. In which situation there is a displacement current but no conduction current? So there is a situation given here where the capacitor has electric field between the plates, not only electric field but also changing electric field. So whenever there is a gap or there is no conductor between the plates of the capacitor, and there is a changing electric field, there exists a displacement current and no conduction current. So that answers the first question, 17th question. Have you understood or shall I repeat? Okay. Now it's question number 18. Moving to the question number 18. Define the conductivity of material. What do you mean by conductivity? See, there are two things, conductivity and resistivity. So how resistivity can be defined? Resistivity matlab it is the measure of opposition to the flow of AC current. Suppose there are two wires. Suppose there are two identical wires, just the materials are different. Their geometries are same, length and area and cross section area, everything is same. Just the first wire is copper and the second wire is, let us say, nichrome. Okay. So when I connect the same battery across both of them, suppose 2-volt battery is connected across copper wire, I notice that 1 ampere current flows. But when the same battery is connected to the nichrome wire, I notice that only 0.5 ampere is flowing. Since the wire is having same length, same cross section area, everything is same, just the difference is material. Because of change in material, I notice that current has reduced. Why? Because copper has less resistivity, so that more current is flowing, and nichrome has more resistivity, so that less current is flowing. So what do you mean by resistivity? It is the measure of opposition to flow of AC current. Flow of opposition to flow of current. It is the extent up to which the material opposes the current. How much it gets opposed, because electron flows through it. Current is what? A flow of electrons. So therefore, when electron flows through the material, then it will be opposed by the material itself. So up to what extent it is opposing is known by resistivity. And reciprocal of resistivity is conductivity. We have been asked to define conductivity. So how to define conductivity? It is the measure of what is the opposite of opposition. Measure up to which it allows the current. And a measure up to which it allows the current. Okay, it is the degree to allowance, you can say, right? It is the opposite of resistivity. Therefore, I can define conductivity and resistivity are reciprocal to each other. Conductivity is 1 upon resistivity. Remember, conductivity and resistivity both depends on material. It depends on Material only. It will be independent of length and area. Length and area पे independent होंगे. Resistivity is different and resistance is different. Remember, conductivity is different and conductance is different. Conductance is the overall opposition it is getting. Overall opposition. But conductivity is the opposition by a single wire. One wire. 1 meter wire, 1 meter cross section area. So conductivity is also known as specific conductance. Specific conductance. So it depends only on material, not the geometry of the wire. Okay. So also it slightly depends on temperature. It slightly depends on temperature. When temperature increases, conductivity of metals slightly decreases. Remember, with temperature, the conductivity of metals or conductors slightly decreases. So how can we define its unit? Now, unit for defining the unit, let us define the unit of resistivity first. Then we will say that since the conductivity is 1 upon resistivity, the unit will be reverse. So pay attention. Do you know this formula? R is equal to rho L by A. Resistance of a wire. See, consider this is a wire. Okay. The wire is having length L and cross section area is A. Okay. What is this rho? Rho is called resistivity and R is called resistance. I told you resistance depends on length and area, but resistivity is independent of length and area. Therefore, resistivity can also be written like this RA by L. Now I will write unit. What will be unit of resistivity? See, for R I will write ohm. For area I will write meter square. For length I will write meter. So meter and meter gets cancelled and resistivity का unit आ जाएगा ohm meter. So ohm meter is the unit of resistivity, but we have been asked to find unit of conductivity. Now conductivity is what? Conductivity is 1 upon resistivity and conductivity is represented by sigma and 1 upon rho. That is equal to 1 upon rho. So therefore unit of sigma will be 1 upon ohm meter. Ohm 1 upon ohm meter means ohm inverse meter inverse. So ohm inverse can also be written like this. See, reverse omega. So ohm per meter, mho per meter. This is read to be mho, reverse of ohm. The reciprocal of ohm is mho, reverse of ohm. Because it is reciprocal, no? So that's why it is written reverse. So we have defined the conductivity. It is the reciprocal of resistivity, and it depends on material. It slightly depends on temperature also, and its unit is mho per meter, or ohm inverse meter inverse. You can say. Okay. Now, how does a circular loop carrying current behaves as a magnet? How does a circular loop current carrying behaves as a magnet? Now pay attention. See, consider there is a circular loop. Consider there is a circular loop. Now, question number 19. When this circular loop is carrying some current, there will exist some magnetic field around it. Because due to this current, there will be some magnetic field going like this. In 3D, you can imagine. Magnetic field will be inside the loop, na? It will be inside the loop. Everywhere it will be inside the loop. Now, since the magnetic field exists, we can say it behaves like a magnet. But the question arises here is, what will be the magnetic field at the center of the circular coil? The magnetic field at the center of the coil can be derived using Biot-Savart law or Ampere-Circuital law. So using Biot-Savart law, we can derive. Do you know what is Biot-Savart law? Biot-Savart law. What is Biot-Savart law, beta? Biot-Savart law tells that magnetic field element due to the element of the wire carrying some current is equal to mu naught upon 4 pi I dl sine theta upon r square. This is called Biot-Savart law. Now using Biot-Savart law, we can derive the magnetic field at its center. The magnetic field at the center of the coil will be, just 2 minutes. Magnetic field at the center of the coil will be dB is equal to mu naught upon 4 pi ideal sine theta. So I will apply the Biot-Savart law for the circular current carrying wire. Consider this is a small segment carrying some current I. Okay, let us say its length is dl. Now I want to find the magnetic field at its center. So this dl will be having a distance of r. R is the radius of the loop, right? So the magnetic field due to this elemental segment will be mu naught upon 4 pi I dl sine 90 I will write upon r square. Why I have written sine 90? Because what is theta? Sine theta में जो theta है, what is that theta? Theta is the angle between length vector and radius vector. Now see, what is the length vector? It is directed along the tangent, and radius vector is radius. And we know using geometry, we know that tangent is always perpendicular to the radius. Tangent and radii are perpendicular everywhere. So therefore, I will put 90 degree. ठीक है? So therefore, dB becomes mu naught upon 4 pi I into dl upon r square. Now total magnetic field. This is the magnetic field due to the small segment dl. Total magnetic field, I will integrate this expression. I will integrate this expression, right? Because for every segment, I will after integrating for every segment, I will add the magnetic field. Now magnetic field becomes integration. I will put the value of dB mu naught upon 4 pi I dl upon r square. Now we know that using integration we can take out commons. We can take out which are constants, right? So mu naught upon 4 pi is a constant. And see the loop. Every loop has same current. Loop is having many segments of dl length. Every segment of length dl is having same current. Therefore, current is considered to be constant everywhere. Current is constant. Therefore, I can take current I outside the integration, right? Also, for every segment, see this segment, every segment is having same distance r. Every segment of the loop dl is having same distance r because radius is same everywhere. So radius is also considered to be constant. Therefore, I will take out r square as well. And inside in the integration only dl remains. So what does this integral dl means? Integral dl means length of the loop, total length of the loop. Now see the loop and tell me what is the total length of the loop. What is the total length of the loop? It is the circumference, right? What is circumference? 2 pi r. Can I put 2 pi r? So at the place of integral dl, I will put 2 pi r. Mu naught upon 4 pi I upon r square as it is. Integration dl की जगह मैं क्या रखूंगा? 2 pi r. So therefore some things will be cancelled. Pi से pi उड़ा, 2 से 2 उड़ा. Therefore b will be equal to mu naught I upon 2r. This is the magnetic field due to magnetic field at the center of the loop, center of circular loop. Have you understood? So using Biot-Savart law, we can not only find this is how it behaves like a magnet because it gives you magnetic field. You can conclude after this integration, you can conclude that since the current carrying loop is producing magnetic field at its center, it behaves like a magnet. Okay? Yes. Are you done? Now see, in the next question, they have given a numerical. The current flowing through a pure inductance. The current flowing through a pure inductance 2 millihenry is. Now see, question number 19. Given that self-inductance is 2 millihenry. Now, what is milli, beta? What is milli? Question number 20. So, milli means 10 power minus 3. Do you know milli means 10 power minus 3? Okay. So, 1 milli is equal to 10 power minus 3. And the expression for current is also given. See, 15 cos 3000 T. 300 T. Right? 300 T. And unit is ampere. I will not write unit. What is the RMS and average value of current for a complete cycle? Average value of current for a complete cycle, right? And RMS value of current for a complete cycle. Now, uh, we have since the question is only for 2 marks, I will directly write we have solved it for average value of current. In AC, the average value of current for one cycle is always 0 for one cycle. And what about for half cycle? For half cycle, the average value will be equal to, do you know? It will be 2 times I naught upon pi. And what is the RMS value of current? RMS value of current is I naught upon root 2. Amar Akbar Anthony. Amar Akbar Anthony. Please remember these 3 questions. Okay. Now I will tell you what is going on here. Pay attention. We know that AC current varies something like this, correct? And from here to here, that means this. This is the one cycle of the AC. One cycle of AC, right? So since this is one cycle of AC, I can say that in taking average over one cycle, what I have to do? I have to add all the currents. How to take average of something? Add everything divided by total, correct? So in adding every current like this, I will cancel the positive half cycle and negative half cycle completely, because this value will be cancelled by this value, and this value will be cancelled by this value. So everything will be cancelled when we add it for one cycle. So therefore its average value for one cycle is always 0. Correct? But when we add them for half cycle, it will be 2 I naught upon pi. Because in adding half cycle, in the half cycle it will not cut na. This is the half cycle. It won't get cut. Therefore the answer will not be 0. So do you want me to derive these equations? Because you are not getting directly, right? So I must derive it. Okay, don't worry. See, pay attention. So I know. Do you understand what do you mean by half cycle and full cycle? So pay attention. I will derive these equations for you. Pay attention. See, let us say x-axis is time. So we know that for one cycle, the time required is equal to period of this AC. So let us say t is the period. So the one cycle will correspond to 0 to capital T, and half cycle will correspond to 0 to T by 2. In 0 to T by 2, there exists half cycle. In 0 to capital T, there exists one full cycle. Understood this? Now, we know that AC current, the standard equation of AC current, I of T is equal to I naught sine omega T. What is I naught? The peak value, amplitude of current. Omega is what? Frequency, angular frequency or angular velocity, right? Now pay attention. This is the expression for current, standard current in AC, right? Now, if you want to calculate average over one cycle, average over one full cycle, what you have to do? You have to add all the currents. Adding all the current means integrating the current. And since the current varies with time, therefore integration must occur with time. So do you know we have added all the currents, but for taking average we have to divide by total time. So therefore I will add time also. Number of samples means what? We have taken the sample with time na. Therefore we have to divide it with total time. So this is what? This is the average current over full cycle. And since we are taking it for full cycle, full cycle, what does time starts from? It starts from 0 and ends at t. So therefore I must write the limits of integration from 0 to capital T, because I am taking the average over one cycle. Now substituting the expression for current in the above equation, I will get, see, denominator will be integrated by capital T na. Do you know integration? Integral dt will be t. After applying the limits, it will be capital T. Right? Now substituting I naught over here. Okay, substituting I naught over here. What I will get? I will get integration 0 to capital T. Right? I will put I naught. I naught sine omega t. So what I did, I took the I naught outside the integration because it is constant. Now integrating sine omega t, what will be the integration of sine omega t? Tell me. I naught divided by t. Integration of sine omega t will be minus cos omega t upon omega. Correct? It will be 0 to capital T. Right? So therefore I average will be equal to I naught upon omega capital T. Right? Omega capital T. I will take that negative outside the integration. Okay? Outside the integration. Negative and omega can be taken outside the integration. Now applying the limits. Cos omega t we have na. So cos omega capital T. Substitute upper limit minus substitute lower limit. What I did, instead of time, I have put capital T as upper limit and 0 as lower limit. Understood? Now we know what is omega. Tell me, what is omega? Omega is 2 pi by capital T. Right? Do you know omega is 2 pi by capital T? Okay, now substituting 2 pi by capital T and into T as it is minus cos 0. Now tell me, this T gets cancelled. What is cos 2 pi? What is the value of cos 2 pi? Tell me, what is the value of cos 2 pi? It is 0. Cos 2 pi is, sorry, it is 1. Cos 2 pi is 1. Cos 360 degrees is 1. See how the cos waveform looks like. It looks like this. So this is where cos 2 pi occurs, na? So what is cos 2 pi? 1. And what is cos 0? Also 1. Correct? So this t or then t gets cancelled. Therefore, next step will be I average is equal to minus I naught upon 2 pi. Right? And cos 2 pi is what? 1. And cos 0 is also 1. What is 1 minus 1? Therefore, average value of current over one cycle is 0. Didn't I tell you it is 0? It is 0. And why it is becoming 0? Conceptually think, this was just mathematics. But see what is happening here. Every current gets cancelled in addition. Since we are taking the average over one cycle, in one cycle there exists positive half cycle as well as negative half cycle. Therefore, adding the currents results into cancellation, everything. ठीक हो गया? So therefore, everything gets cancelled. Therefore, I average is 0. Now let us take average over half cycle. Average over half cycle. Now tell me, how to take average over half cycle? Since we are taking average, therefore we have to integrate the current. How to take average? Adding all the current divided by number of samples. How many samples are there? Total time, right? So since we are doing this, we have done the same thing in the above case. But since we were taking the average over one cycle, we took the limit from 0 to capital T. See the waveform. One cycle exists from 0 to capital T. What about half cycle? Half cycle exists from 0 to T by 2. Therefore, we have to take the limits of time from 0 to T by 2. Mat karo na sir. 0 to capital T by 2. Right? This is what? This is average over half cycle. This is average over half cycle. Therefore, average over half cycle becomes, denominator will be what? Denominator will be T by 2. After integrating and applying the limit, it will be T by 2. Right? And substituting the value of current, 0 to capital T by 2. Current is what? I of T is what? I naught sine omega T. Same steps. Right? So therefore, I average will be equal to 2 I naught upon T. Integration sine omega T is what? Integration sine omega T will be minus cos omega T. Minus cos omega T upon omega. And I will put the limits 0 to T by 2. Correct? So what I will do, I average will be equal to 2 I naught upon T, actually omega T, right? And I will take this negative common as well. And let us substitute the limits now. So cos omega capital T by 2, right? Minus cos 0. What I did? Substitute upper limit minus substitute lower limit. Now you know what is omega. Minus 2 I naught upon what is omega beta? 2 pi by T. And into T as it is. Cos 2 pi by T into T by 2. Minus cos 0. वहाँ चले जाओ. बोलो. This T gets cancelled, 2 gets cancelled. T gets cancelled, 2 gets cancelled. Right? So after simplification, what I will get? I average will be equal to minus I naught upon pi, right? Upon pi into cos. Cos pi minus cos 0. What is cos pi? Cos pi is minus 1. And cos 0 is 1. So it will be minus 2 na? Minus minus gets cancelled. So therefore I average will be equal to 2 I naught upon pi. This is average over half cycle. Average over half cycle. But you don't have to prove it for 2 marks. See, I have proven it for here, but you have to just write it that I average for half cycle is 2 I naught upon pi. You can remember this equation. And the proof is mentioned here. Have you understood? How did I take average over half cycle? Just changing the limits of integration. Rest of the things I have done same. Only the limits I have changed. Over one cycle, I put the limit 0 to capital T. And over half the cycle, 0 to T by 2. Very good. Correct? Now the third thing is IRMS. Now what is the full form of RMS? Root mean square. See, I will write it. I will write it for you. Now the third thing I have to prove is RMS. Root mean square. Current. This is called RMS current. So from this name itself, I can write the formula for RMS current. Now see, what is the first word? Root. So I will put a root. Correct? What is the second word? Mean. I have to take mean of something. Third word is square. So we know that we have a current value I of t, right? First there is a current, then there is a square. So we have the next step is taking the square of current and then taking the mean value. How to take the mean value? I will integrate it. and divide by time. This is how we took the limit. Okay, and since we are doing everything for 0 to capital T over one cycle, I will take one cycle. RMS value is taken over one cycle. Now the idea here is why we are taking over one cycle. Idea here is, see, we know the graph. We know the graph that for one cycle average value was 0. Why it was 0? Because all the positive values gets cancelled by the negative values. Therefore, before taking the average, see, before taking the average, we are squaring the current. So what does the squaring the current results into? Negative values will become positive. So therefore, there will be no cancelling out. Therefore, we are first taking the square of current and then integrating it. First, we are taking. आ गए सर
पढ़ेंगे ना
फिजिक्स केमिस्ट्री मेरा नहीं है कि पहले टीचर को आने दो ना. First, we have to take square of current so that all the negative values becomes positive, and then we have to take the mean value, and then we have to take the mean value, and then we have to take the square root because we took the square. So eliminating the square of the current, we have to take the root. Did you get the idea? See, because for one cycle everything was 0 because positive cycle gets cancelled by negative cycle. So therefore, to make this not happen, we are first squaring the current. Squaring the current will make the negative values positive. Then square of current is taken over average. Average of square of current is happening here. So that the answer would not be 0. And since we took the square, we are taking square root after that. After the average, we are taking square root because we took the square of. So that is the idea behind RMS value. Now the mathematics is very simple. For here, for the sake of simplicity, I am taking this square root on the right on the LHS. Okay. So what I will get? IRMS square is equal to, now see, this square root will vanish and this denominator would be what? It will be capital T, right? And integration 0 to capital T as it is. Now I of t ka square hai na? I of t square hai. So what I of t becomes? What is I of t? I naught sin omega t. Squaring it will make it I naught square sin square omega t dt. Correct? Correct है ना? Because I of t square hai. So I of t is what? I naught sin omega t. So squaring it, I naught square into sin square omega t. Now tell me, what will be the next step? I RMS square will be equal to I naught square upon capital T. Integration 0 to capital T. What is sin square theta? Do you know what is sin square theta? Sin square theta, according to trigonometry, is 1 minus cos 2 omega t upon 2. You have to make mathematics very strong. Huh? Sin square theta is what? 1 minus cos 2 theta upon 2. Therefore, sin square omega t would be 1 minus cos 2 omega t upon 2. Correct? So, IRMS. Now the steps are becoming huge. Huh? I square upon 2t. Inside the integration 2, I took the common. Integration 0 to capital T. 1 minus. Shall I integrate directly? What is the integration of 1? Integration of 1 will be t. What is the integration of cos 2 omega t? Is it sin 2 omega t upon 2 omega? Applying the limits. 0 to capital T. Right? So what I will get after applying the limits? I naught square upon 2t. This will be applying substitute upper limit minus substitute lower limit. Correct? Minus sin 2 omega. Okay, omega t. My mistake. It will be omega t, na? It is cos omega t. So sin 2 omega t. Okay, sin 2 omega t is there, na? So put a substitute upper limit at t. So I will get 2 omega capital T minus sin 0 upon 2 omega, and everything will be inside the bracket. Brackets are very important, just like borders are very important. Brackets are the borders of mathematics, remember. Okay. So what will be my next step? Tell me next step. I square is equal to I naught square upon 2t. It will be t only minus sine. Inside the bracket, it will be sine 2. Omega is what? Omega is 2 pi by capital T into t minus sine 0 is 0. Sine 0 becomes 0 na? Upon 2 omega. Now tell me, this t and t gets cancelled, beta. So what is sine 4 pi now? According to trigonometry, it is 0. The value of sine 4 pi is 0. Okay. So this entire thing becomes 0. So I will eliminate it. Only t remains, na? Only t remains. So therefore this t and this t gets cancelled. And the next step would be I RMS square is equal to I naught square upon t upon 2, sorry. So taking square root on both sides, what is I RMS? It will be I naught upon root 2. Understood? So there are three derivations: average over one cycle, average over half cycle, and average over root mean square value. Here it is expected to write it directly. We don't have to prove everything because the question is only for 2 marks, I think. Okay. So therefore you may write everything. You don't write everything. Okay. For the sake of your understanding, I have explained everything, but you can write. See, I will write. I is what, beta? I is equal to 15 cos 300t. This is given. Now, what I will do, I will compare it with the standard equation. What is the standard equation we have? I naught sine omega t, right? So, shall I write this equation in terms of sine? Yes, I can write. I naught cos theta can also be written as sine theta plus 90 degree, right? Theta plus pi by 2. So now can I compare it, beta? Sorry, this is 15, no? 15. Can I compare the equations? Comparing it with the blue equation. Follow. I naught will be equal to 15, right? Unit will be ampere. And what is omega? Omega will be equal to 300. Radian per second is the unit, right? Now, we have been asked to find, for the first case, we have been asked to find what is the RMS current. First time they have asked to find IRMS. We know the formula. What is IRMS? It is I naught divided by root 2. That means 15 upon root 2. Now, how to solve it? Multiply and divide by root 2. Root 2 into root 2 is 2, right? So 15 upon 2 into root 2. What is 15 by 2? It will be 7.5. And what is root 2? Root 2 is 1.414. The value of root 2 is 1.414. Multiply it and write the answer. Okay. I will give you one satta. See, there is a satta. Do you know what is satta? Where are you from? Manipur. Very good. Do you know Zakaria? Zakaria is also from Manipur. He has studied from it, from ADCI. Recently, last year. What is your name? Kedav? I will introduce Zakaria to you. Okay, see. 1 upon root 2, na? 1 upon root 2. जी वही बोल रहा हूँ मैं. I naught upon root 2. So there is a shortcut of it. The value of 1 upon root 2 is 0.707. And I naught as it is. Correct? So this will be much easier. I will write 0.707 into what is I naught? It is 15. Now I just have to read the table of 15. Now tell me, Kedar Ping, what is 15 sevens? Yes, very good. 105. So I will write 105. Carry 1. Now what is this? 15 sevens again? It will be 106. Correct? So see, this is my answer. 10.605. So this is very difficult to multiply. It will take your time. So you can remember this. In ADCI, we call it Satta. Shortcut is nothing but Satta. Do you know the word Satta in Manipur? Okay. Second. Now see, second. Average value of current for a complete cycle. What is average value of current for a complete cycle? Bolo? It will be 0. Yes, very good. For one cycle, right? For half cycle, it will be. Now, half cycle is not asked, but I can solve it. What is for half cycle? 2 I naught upon pi. Now, there is one more satta for this. Okay, shortcut. 2 by pi, the value of 2 by pi using calculator, you can see it's 0.637. Okay, let me check. Long before I did this, let me check. It is 2 divided by 3.141. Yes, 0.637. Okay, this I naught as it is. Now, using this shortcut, I can very easily do it. 0.637 into 15 because I naught is 15. Now, again, tell me 15 sevens are carry 10. 15 threes are 45. 5 carry 5, right? 15 six are 90. Plus 6 plus 5, 95. 9.555 ampere is my answer. This is the average value of current over half cycle. But we have been asked to find average over one cycle. Therefore, I will write 0. Correct? So that solves your question number 20. Understood? Are you wishing to write this?
Actually, I'm still starting the chapter from.
Okay. You must start from beginning. You are here for NDA? Neat. Okay. You have passed 12th? You are 12 plus students. Okay. You are repeating for NEET. Okay.
Not the basic experience physics of taking something again.
Okay. Nice. Okay, we'll start with the 12th. Now, right now, exams are going on. That's why I'm solving the sample paper. We will do it from scratch. See, I'm taking question number 21. State the criteria of phenomena of total internal reflection of light to take place. Now, what do you mean by total internal reflection? See, if there is a boundary between two media, consider that the upper medium is rarer medium, like air, vacuum, like this, and the bottom lower medium is denser medium. So when the light comes from rarer to denser medium, denser to rarer medium, the light bends away from normal, right? We know that when the light goes from denser to rarer, where does the light bends? It bends towards the normal. Now student forget this towards the normal or away from normal. Therefore, we have make a satta for this also. You can remember to draw. To draw. See how to use this satta. 2 say towards, D say denser, R say rarer, and AW say away. Now when the light goes from denser to rarer away from normal, and rarer to denser towards the normal. That's how you can remember this. So therefore, you can apply a denser to rarer because the light is going from denser to rarer. The light bends away from the normal. Now, what if I increase the angle of incidence? For the next ray, I will increase the angle of incidence. Now it bends more away from the normal than the previous ray. So bending will make the ray like this. The light may bend so much that it traces the boundary between the media. Ajay, ma'am. The light has bent so much that it is tracing the boundary between the two media. Right? So therefore, this ray is known to be critical ray. This ray is a special ray called critical ray because after this ray, something else is going to occur. When angle of incidence is increased, then what will happen? Now, the ray will try to bend more than this ray. Okay. So what will happen? The ray will go inside the medium also only. See, the previous rays has changed the medium of propagation. It is entering into another medium. Therefore, these are known to be refraction. But this ray, this particular, after the critical ray, the ray is going to into the same medium. Therefore, it is not refraction, it is reflection. The light is not entering into the another medium, it is entering into the same medium. Therefore, the phenomena is called refraction. And since the total internal reflection occurs, name itself is explaining the phenomena. The light gets totally internally reflected. Not only a single ray is going into the other medium. So therefore, it is called total internal reflection. Now, critical ray is important, no? So the angle at which this ray traces the boundary is called critical angle. The angle of incidence at which the ray traces the boundary is called critical angle. After the critical angle, total internal reflection occurs. Now, before the critical ray, total हो गया sir. Total internal reflection doesn't occur. Total internal reflection occurs only after the critical ray, right? Before critical ray, there is no total internal reflection. Therefore, I can conclude the second condition of total internal reflection, that angle of incidence of the ray must be greater than critical angle. When it is less than critical angle, total internal reflection doesn't occur. This is the second condition. What about the first condition? First condition of total internal reflection is the ray must go from denser to rarer. Because think in a reverse way. When the rays was entering from rarer to denser, it bends towards the normal. It will never do total internal reflection. Because for total internal reflection, the ray must trace the boundary. If it is doing opposite way, it will never trace the boundary. It will never enter into the same medium. So therefore, the very first criteria for total internal reflection to occur is it is from denser to rarer. The second condition is angle of incidence should be greater than critical angle. These are the conditions of TIR. Now, what is TIR? Total internal reflection. Have you understood the lecture? Okay, bye everyone. Take care. Hi. Give me your number. इनकी इनकी क्या इंड मैं समझा नहीं इंड कीजिए ना इस पे ये एंड हो गया लेक्चर एंड करो